हेलो। हेलो।
गुड इवनिंग सर।
गुड इवनिंग, गुड इवनिंग एवरीबॉडी।
सर मैं पीयूष गुप्ता हूँ सर, मनीष सर के ऑफिस से। तो सर हम लोग स्टूडेंट का वेट कर रहे हैं, उनको इन्होंने देते हैं तब तक 2-4 मिनट का टाइम देते हैं। हेलो।
हाँ, हेलो।
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 यस सर, आपकी आवाज आ रही है।
आ रही है ना?
जी जी
सो
सर।
शुड आई स्टार्ट नाउ?
आ, करते हैं सर, स्टार्ट स्टार्ट कर देते हैं सर, स्टूडेंट्स आते
ओके।
रहेंगे।
ओके।
सर नमस्कार।
नमस्कार सर, नमस्कार। सॉरी फॉर।
थैंक यू सर फॉर ज्वाइनिंग।
हाँ।
आपका बहुत बहुत स्वागत है। आज हम लोग मिल रहे हैं मिनिस्ट्री ऑफ एजुकेशन सेल इंस्टीट्यूशन इनोवेशन काउंसिल के चैप्टर 3.4.0 के तहत, जिसमें कि आज हम प्रोटोटाइप और उससे रिलेटेड चीजों के ऊपर आईआईटी बीएचयू के सीनियर प्रोफेसर संतोष कुमार जी के साथ बात करेंगे, जो डिपार्टमेंट ऑफ मैकेनिकल इंजीनियरिंग में है। सर आपका बहुत बहुत स्वागत है और मैं अब आपसे निवेदन करूंगा कि आप आज अपने सेशन के बारे में लोगों से बात करना शुरू करें। वेलकम सर।
सो थैंक यू डॉक्टर अरोरा, मनीष जी, giving me this opportunity to share some of the issues that relates to product development and prototype.
सर आपकी आवाज नहीं आ रही है।
नहीं आ रही है? Is it so?
एक बार अनम्यूट कर दीजिए। सर अनम्यूट कर दीजिए, अनम्यूट।
Now it is coming. Is it okay?
पीयूष आवाज आ रही है आप लोग को?
हेलो।
पीयूष पीयूष आवाज आ रही है आप लोग को? बाकी लोग ऑडिबल हैं? ज्वाइन किए?
सर बिल्कुल परफेक्ट आवाज आ रही है सर,
हैं?
बढ़िया आवाज आ रही है सर, परफेक्ट।
Are you able to hear me, all of you?
सर
You are
मेरे
able
एंड
to
पे
hear
आवाज
me or
अच्छा आ रहा
not?
है।
हैं? Are you able to hear me or not? Hello? Are you able to hear me or not?
यस सर।
Huh?
यस सर, वी आर गेटिंग योर वॉइस सर।
Okay, then I will start now. I will start. See, the topic which is given to me is on uh, the workshop on prototyping, process of design and development. That is the product development and prototyping, right? This is the topic which is given to me. So I will share my screen first. Let me just have it and then I can start it. So just a minute. So are you able to see my screen? Are you able to see my screen? Hello?
Yes, sir. Visible.
Are you able to see my screen?
Yes, sir.
Okay. So let us see, what do you mean by product? A product. Eh? Say the product is means any physical objects which one would like to either make it or modify the existing one to a relevant one, or making a something making based on the need analysis. For an example, how do I say a product? Let us understand that. See, there was a corona period and there was a need that there should be a vaccine, right? And then there was a problem, corona problem, and there is a need of vaccine where the vaccine has then therefore come as a product so that the society can be benefited. So the coronavirus, the need is have a solution. So solution is, let us design, develop a virus vaccine. So vaccine is a product. How did it evolve? From the need. Similarly, any product, either it is a totally new like corona problem, or maybe something existing and then you want, for an example. So the two type of product A, which is fully new based on the new needs, and second, which is already existing in the society, but you want to have a better format of the product, either in terms of the cost or in terms of the efficiency or in the terms of better technology, like that. So that is called as class B product, right? Class C product is called as where no, the things are there, but I want a totally entirely different technology for that. So first example I have given, class A, the coronavirus need as a vaccine, and then vaccine you have to develop it, lot of research, this, that, and you develop it. So that is a product A, class A. Class B, I said, there is something available. Say there is a bicycle, you have bicycle already available. Now you want to have a e-bicycle. There is a need today that let us put it electrical bicycle. So what you are doing? You are taking the existing bicycle, you are modifying it, you are adding motors, this, that, and then you are making the convert the bicycle into e-bike, and so that's the product class B, right? Class C product is it may exist, it may not exist, but you want an entirely different technology for the, suppose it is for the existing, then you want to have it entirely different technology, right? For an example, you have lot of vehicles, electric, this is scooter, this, that runs on petrol or diesel. So now entirely different technology you want, like you use of hydrogen vehicles. Let us go for the hydrogen vehicle, zero emission. So that is the class C product. Are you getting? Hello? Hello everybody?
Yes, sir.
Are you able to hear me now?
Yes, sir. We can hear.
So my screen is visible to you? My screen is visible or not?
Yes, sir. It is visible.
Oh, good one, good one. So then I said, so this is the product. Now you want to make it quick. So what I say, there is a rapid design development so that you make the manufacturing of the product quickly. So that is what we call a scenario, which is called a rapid design, development and manufacturing. Okay. So in this direction, there are two issues which is called as design problems. Say you have decided from the need, say that's how there is a concept. So the need has to be converted into functions. For an example, coronavirus. So is that vaccine you require. So need is a vaccine. So how the vaccine should, what the vaccine has to do, how it has to solve the health problem. So you have to study. Na? So that is what is called as what function this vaccine will perform. So you have to analyze the functional analysis. Then it is called as functional analysis, right? So once you identify the functions, these functions will be correlated with the doable things to be converted into design. Now I come over here. Just look at this figure. This is a concept. So what is my concept? I have to develop a vaccine that helps. And then now because the product basically a physical item. So I will develop the concept. So developing a concept is what? Developing a concept means functions. So what the product has to do, based on the need, identify the functions and convert these functions into doable things. Means, for example, the function means now the bicycle has to run by electric. So what is the function? How it will run? You require a motor to drive. So first function is drive with a motor. First function. Second, you require electricity. So you require so second function is you require a battery. Then third function is it has to accelerate, decelerate. So you require a electronic card that will coupled with the motor and battery, right? Power supply as a power supply as the battery. So these are converted into functions. And then once the function is there, then you go for the design. And then you go for the design. Eh? So this is the new concept. And here the second one which I am saying on this right side, a sample, that is the already product is already existing and you want to make the reverse engineering, means product is there and you want to study what are the components, what are the size and all that, and you note it down so that you can modify the design and make another new product. So that is the different class B one I said. Now let us come to the first one. So in the concept, based on the functions, you convert into the relevant functional analysis and decide the components, right? You decide what component to provide these functions. What are the components? Like in bicycle, I said electric bicycle. The components are, that is motor, the electronic controller card, battery, and some of the mechanical components where you have to assemble and weld and all those things. So these are the components you require. Then these component you have to, because it is a concept, there is no existence of physical product. It is a concept level. So deciding on the function, deciding on then what you require component, and this component is then further designed, mechanical design. And then you design the material of the components, you design the shape and size of the component, and then you make the CAD model of it. See now here it is CAD model. CAD model is what? It's a soft component of the model, computer component of the model, where you will be making it, right? So that is how to create the CAD model for the different For an example, I will show you. I will show you one here. Just let me show you what is CAD model. Are you able to see my screen now?
No, sir, it is not visible.
The screen is not visible, my screen.
No, sir.
I shared it. Okay, so I will share it again. Yeah. Now, are you able to see now?
Yes, sir.
Okay, good. So now see, I will show you one model. So I will show you one model. Uh, are you able to see this model? Hello? Are you able to see this model?
Yes, sir.
What is this?
A cup.
Yes, exactly. So this is a model, computer model of it. And now I can see it in anything. I can rotate, I can see any detail. Even I can measure the dimensions of it. Say I want to know how much is this dimension. So I can see it is 73 mm, something like that. So 42 mm, something like. So I can measure all the things. So as if it is a actual model, physical model, but it's not a physical, it is a computer model. Got it? So for an example, this is the diameter, radius, and all that I can see. Any dimension I can know. I can see how this looks like. So I can change the color of it. I can change the color of it. For an example, I choose this. So I can make uh, I can have the say I want to, so anything I can do with this so that I can decide the how my product would like. I can make it whole or anything, many things I can do it with this product. So it is a one of the component that based on the concept I designed it. Now let us take another example. I will take another example here. Look at this. What is this? Can you guess what is? Huh? Hello? Hello? So this is another model. Okay. Is it? Is it? I will go other model also. I will take this also. Now this is another model. Okay. Are you able to see it or not? Hello? 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 Manish ji? Hello?
Yes, sir.
Are you able to see my screen or not?
Yes, sir. We can see.
So now this is the another product. So I mean to say that you are designing something from the concept and then component depending on the functional analysis and then deciding the component, and these components you are drawing in the computer. Okay, so like these are the components. So I can play with this. See, I can delete this part, I can delete this part, or I can add anything. So like that, see, I can change the dimensions also. I can make any dimension. Say I want to scale it up, so I can make it say, see, the scale, anything. So as if it is a regular thing. So according to my product I want to do, these components can be modified with respect to its material. For an example, the material is what here. See, I see the details of it. This material is steel here. I can make anything. I can make it as a aluminum or whatever. It is up to me. So it's a platform which is computer aided designing, the platform where based on your design concept you can convert into it, and then you can, as per your design, and you can finalize lot of iteration you can do before coming to the final product. Is it? So that's the what I was trying to show you here in this figure, particularly this particular figure which I just opened it, this one. So this is the CAD model. Now you see, you use some of the software, CAD software which I have shown you now. Now based on this CAD modeling you will do structural analysis, optimization. What is structural analysis or optimization? That is means whatever you are going to make it on the screen, you have to see whether it will be physically, it will be able to take load, whether it will be work in the physical mode or not. That you do lot of mathematical analysis and optimization of the shape, size, color, all those things you do it here. And for structural analysis, because everything you are doing it on the virtual platform with computers, so you require, for doing this structural analysis, you require a lot of other analysis packages like ANSYS, MARC, Moldflow, and many more things. If there is some forming things, then you can use deform and all that. And once this is done, then you will go for the fabrication of the simulation. Means now you have finalized the product, and then you go for the prototyping. So here is the, so you have finalized the design, you make the prototype of it. The prototypes can be made in many ways. You as a artist, you can use clay, you can use wood carving and all that. You can make the models of individual component. And other way is your rapid prototyping. So I will come to that because my main talk would be on the rapid prototyping. So the fastest way, now here once your CAD model is clear, you need not to go for the making a model using a clay or wood or any other method. You can directly make the model with the CAD model which you have made in the computer. So that making it, so that is called as digital modeling. Digital prototyping. So digital prototyping you will be doing with this which is called as rapid prototyping method. And there you can print it, that is also called as 3D printing. You can print it on and you can see the exactly what you have made it on the computer. And then physically you can provide load, you can run whether it works or not, you can see that. So that is quickly, very quickly you can make. Otherwise, when you make it of the sculpture, then fitting, assembly and all those, it will take a lot of time. But here prototyping will be done very fast. It can be done fast. Okay. You can test also. While testing, if it fails, then what you will do, you will again come back to the here design, you will redesign, you will make again changes in the CAD model, again analysis, then again you make the prototype and again test. To support this prototyping and you can have rapid tooling, because when you make the prototype, so you require number of pieces to be made. So require rapid tooling and then you can go for the mass production like manufacturing. So I'm not going to come. So what you got my things. So this I discuss for a product based on the need analysis. Based on the need analysis, you will clearly modify its functions. You find out the functions of it. Then based on the functions, you will decide what doable things are required for to complete this function. And then you will make the component, and then you make the component in computer, not physically, so that you will be able to do the faster, more visibility as I have shown you in this software. So, and then you will make it a prototype and then you see the actual test trial. And if there is a something wrong, then you redesign, remake it, and then again. So that's the iterative process. So you will see that starting with the CAD, the concept is converted into CAD modeling, then it is analyzed for the functional analysis and testing trials. So so everything is now being done as your digital method. Okay. So now let me come to the other thing which I would like here. Just 1 minute. I am sharing. So let us now look at this slide. I am not able to locate my slide, but I think I will concentrate on this particular slide. So let us look at. Now you see, what do you mean by rapid prototyping or 3D printing, right? Just look at the converting a product into very quickly into a final product for manufacturing. This is a scenario where the growth of additive manufacturing or 3D printing is supposed to have here with time here. See, presently we are here because digital manufacturing, it is which is coming now. It has already emerged in India and most of the other countries. So it is very easy to use, and it does not require much expertise, and so the growth is going like this. It is in time to come. Now presently we are here in, say, this is in 2010. So now you can have here and it will further very fast growth it is to come, right? So it has to come like it is called as third industrial revolution, like here. So where you will be doing digitally everything, and so it will come true as the actual one, like here. So you are making digitally a car, you are making a digitally a aircraft, and it will fly by doing this. So now you can also print your electronic components like thin films. You can print with additive manufacturing, and also you can have like all electronic chips which is going to be printed, uh, and it has a lot of big business, right? So as a state of art of, because I'm just coming to show you, and then I will briefly tell you the method. How does it additive says? Additive means you make the products by adding the material, not wasting the material. For an example, when you may make a sculpture of clay, how do you make? You make a clay, and then according to your idea you put it, you add the material, and then you shape and size. You also cut the which is not required, right? So that is the way. But here the additive means you don't have to waste material, and by adding according to the design format you go on adding, don't have to remove. Like, so whether it is a small component or bigger component, all that you can do. For an example, these are the things. Circuits you can print, right? You can also print your houses. So that is a prototype. You make the house in your computer and then print it, the house as 2-story, 1-story, like that. So that is now feasible with prototyping. Like this one, or like any other things, many things you can have. You model it and then make it. So this is one of the tire of the 3D printed tire. Now you see much strength than the, it is one piece printed tire. You don't have to, like the other, you have a rim, you have to put the tube, you have to put the tire, but it is a single piece tire which is 3D printed. Like here you are going to print the car, then print the car. So I'm just coming to this particular part where you are to let us come back again to the just 1 minute. Just a minute. Now, before that, let us look at some of the figures. Let me just show you one printer so that you can come across to have. Are you able to see? Hello? Hello? Are you able to see the screen or not? You are able to see my screen or not?
Yes, sir.
You are able to see this, na?
Yes, sir.
So what is this? What is this? Now it is being printed. See, layer wise deposition. This is the prototype. This is the printed prototype. Look at. So this is the processing of the prototype later. So you are putting a wax coating over it. So it will look very smooth. Are you able to see it? Hello? 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 You are able to see it?
Yes, yes, sir.
Okay, now let us look at another one. How this works. So here is the one
Sir,
CAD
just a
model.
moment. Sir, just a moment. The PPT is not showing right now. Please reshare
It
it.
is not going.
Yeah, आप दिख रहे हैं सर. एक बार PPT शो कर दीजिए. शेयर ऑप्शन शायद बंद हो गया है.
अच्छा, okay, just let me see it. Is it now coming? Now it has come.
Sir.
Yes,
Yes,
sir.
yeah. Coming.
So now this is where a model is being created. Now look at. So this is the whole step where the model is being created, and after that model it is being printed. Now you just see, this is a metal printing. So deposition of layer wise prototype. So this is the prototyping. See, now look at, this is digitally printed. The same model which you designed it. Now look at. Okay, now you just look at. Okay. Now let us, what is this? What is this? Anybody? Hello? Manish ji? Manish ji?
यस सर, सर दिख रहा है, जलेबियां बन रही हैं।
Oh, ah, jalebi ban rahi hai. Yes, yes. So now you see what he is doing. This is the manual prototyping. See, the material is being added and it is directly converted into a prototype or direct product. It is a direct product. Is it?
यस सर, यस सर।
So I mean to say that when you make a prototype, there is a instant quickly making of the prototype, because prototype is not the final product. Prototype is a midway process of whatever you have designed, whatever you have developed. Let it to make it a physical form through computer, and that prototype will give you a realization that yes, what I was thinking, it will look like physically like here. But it is a midway, right? So now I will not go into detail. I will stress more on prototyping itself. So let us come to the fundamentals of additive manufacturing. I am just coming it to you. Just a minute. Just 1 minute. So you are able to see this screen? Are you able to see this screen?
यस सर, यस
Yes, sir.
So let us see what is the basics of prototyping. It has three basic stages: pre-processing, building, and post-processing. Okay. How does it work? So first you make the CAD model. Whatever you want, you have in your idea, whatever you have your concept, you convert it into a CAD model. Now there is a CAD model. So there are method of CAD modeling is an entirely different area. I am not going to discuss it. So that is what is the CAD model. Then the second is pre-processing. This CAD model how do you want to print? Before that, the current model has to be converted into some of the pre-processing process, like you will convert the whole model into small pieces, layer wise, because you will be depositing layer wise material. So you have to process the model into different layers. So you cut it into different layers. Like you have a apple, you cut it into different chops, na? So every piece, and then you add, so it will be complete apple. So likewise, you will cut the whole thing into a small thin layer. The layers are, maybe it will, the layers depending on the how do you want the printing, it may vary from 1 mm to 0.5 mm to micron also. So that's a different story. So that is called as pre-processing. So here you slice the component, then make the support. You want to add the support, and then the second is this layer are converted into a machine instruction, that is called as RP process, which is, so that these layers are sent to the digital layers are sent to the CNC machine, where it will build the prototype one above, right? And then once you build it, so the fourth step is post processing, because you will remove, as in the you have seen in the video, you will remove it, you remove the support, you clean the surface. Post curing means you can sometimes require to put into the furnace for sintering and all that, and then the part is completed. Like in the previous you had seen, it was to be dipped in a wax and then it was there. So that's the simple fundamental of any additive manufacturing or 3D printing or prototyping process. That's the fundamental. Three steps, rather it is a four step is post processing. Now I am coming to the what are the advantages of prototyping. So the main advantage is that very short period you require to market a product. Development time is also reduced. The cost of change also reduces. Like if you have a different phases of the development, the cost is here. Like the conceptual modeling, you have some cost. Then detailed design, you have prototyping, manufacturing, product release. So this is the phases has a different cost. So you will see the prototyping improve the product quality, and it enables more design iterations in the given time. Visualization is also there, as you have already seen. 3D visualization. You just see this screen is appearing 3D na? In the screen. 3D is down, this red one is up, and see it is looking the depth perception. Then there are different types of technologies which is available for prototyping. Like the first prototyping machine which was available in 1988, which was stereolithography. After that, there is another technology which is called as fused deposition modeling. Another it is selective laser sintering method. Another is laminated object manufacturing, and the fourth is your 3D printing method. Okay. Stereolithography is one such process where there is a laser and there is a liquid which is a photoresin, and this laser wherever it falls it will solidify, and likewise every layer is solidified and one above, and then the product comes out. This platform, it goes up every layer thickness. So you will see that there are a lot of other technology, like here is the fuse deposition. So I will show you the fuse deposition video so that you can understand. Just let me come over here. Just let me open it so that let us look at this figure. So I will share once again, I will share it. Look at this figure. This is a printer where the
सर
things
नहीं
are
दिखाई दे
going to be printed. So this is the printer and there is a CAD model which it will print. So this is the size which I want to print it as a prototype. So you will see that I first make the model, CAD model, as I said. I am making the CAD model and see this is my CAD model, right? So you can see, you can modify. So that is during the conceptual design, you can do all the things. Then you will bring this CAD model to the printer now, and this the printer starts printing. Just see. Layer wise, right? So this is what is the layer wise printing. Now you see, this is the nozzle, filament comes and it prints according to every layer. Now you see this is being printed. So this is a CNC machine which is digitally controlled every layer as per the CAD model you have made. Now you just see it is printing layer wise. Are you able to see?
Yes, sir.
Hello? So you have developed the prototype very quickly. See, you had the concept, you converted the concept into computer model. That computer model is given to the printer and now you see this is the physically available. These are the support material which you will require to remove later. Now you just see it is the third step where you will be, so this is the printed model. You got it? And then after coloring and that, this is the prototype which you got it. So these are the different prototypes you can make it. So this is another prototypes you can make. Okay. Now let us look at another one. Now let us see, this is another one which is a different technology of prototyping. I am coming to that. This is another which is the resin based stereolithography I told. Now look at, this is the resin I am pouring. I want to print in resin the stereolithography technology. Now you see with the laser it will solidify. So they are FDM printer, DLP printer and the another laser. Now look at, this is the FDM filament which will get plastic, melted plastic is used for printing, right? And this is the liquid resin. Now you see how does it work. So there is a laser. Now this is the printing. Now you see this is the DLP. This is the FDM on FDM and SLA, DLP and SLA. Three different technologies. You require, as I said, you require a lot of motors, movement, and all those very accurate motion, XYZ motion according to the layer, because it's a now see, this is one of the model. This is another model, and you can print prototype like here, and then finishing and all that you can do. So this is the DLP one. This is the one which you have got a DLP one, very fine. You have to cure the model. So this is the model. So these are any model you can make. See, this is the another one which these are the different DLP models that you can print. Wax material can also. So this is the ornamental printing, and then you can make the golden. So these are the finger rings that you can print. So I'm coming to the another one. I will come to the metal one. Metal 3D printing. So now look at this one. You look at this one. You are able to see or not my screen?
सर दिख रहा है.
Hello? दिख रहा है ना?
Yes, sir.
So now you see, this is previously you have seen the plastics to be printed, but it is not that. Metals can also be printed. Now this is the example where, so the process remains same. You will make a CAD model, and there is this CAD model, the 3-step process, and then you can print it. Like, so these are the printed metal parts. You can print at a time many pieces, and then you can sinter this component. Sintering means it will be very. So you can then machine also. You can see this is the what printing is going on. So there are in metal also there are different technologies for micro to bigger products. So this is what another technology for metal printing is stainless steel printing. It is FDM based. Now so most of the metal printer require metal powders for printing, like here. So this is the metal powder which you have to load into the machine, and accordingly you can print. But metal printing is very costly, like here. Printing. So now look at this one. Very interesting one. I just wanted to show you. So this is a lady. Is the data is scanning is done. So there are 3D scanner. So that the whole body is scanned. Now this scanned data is converted into CAD model, and then you can print it. Now you see it is now printed the same scanned data, and it in color. Now just see. So this is a powder based 3D printing process. So now you just see this is the scanner where it is just showing you, and this is the printed model. Mother and girl, daughter, both are 3D printed in color, right? So you can, that's another application for film industry and many other like this one. Now let us come to the so what I mean to say that you are able to see this na screen.
Yes, sir.
So the fuse deposition is one method, as I said. Then there is a as I said, that there is another method which is called as laminated object method. Then there is a, so I am not going in details of it. Then there is a method which is called as rapid tooling, as I said. So that's a thing. So your purpose is to convert the model from idea to the concept into the CAD model, and then prototype. And this prototype, you can test it. If it is not proper as per you require, you make changes again. So that's the iterative process. So prototyping has become now very, very important. Right now the days has gone where you have to wait for you have idea, but you are not able to make the prototype. Now those days are gone. Single person can make the idea, can make the CAD model, can print it, and can develop a product. And then you may go for manufacturing, mass manufacturing or whatsoever. So that's a different activity. So just 5 minutes. Hello? हाँ हाँ उसको रखिए, कल करेंगे। तो परमिशन तो वो तो उनके सुपरवाइजर दिए हैं क्या? तो ही विल बी रिस्पॉन्सिबल ना। हाँ दे, अच्छा मतलब उसको सुपरवाइजर ने कहा है कि चाबी हमारे पास रहती है। हाँ नहीं 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 नहीं, आप सुपरवाइजर को दीजिए, सुपरवाइजर उनको देगा और उनसे कनेक्ट करेगा। हाँ आप सुपरवाइजर को दीजिए। नहीं तो की विल बी गिवन टू सुपरवाइजर, उसमें लिख दीजिए he can be given to supervisor and supervisor can hand over to the student. बस इतना लिख कर भी दे। हाँ right now I come back to the another story so that you can understand within this short period the what is the things when you have some idea and you are waiting for the product to launch it, but how you will go for. So that's the basic thing, but let us look at, so product development process. Let me just open it. Just one minute. I'm just coming to the very interesting story now. You are able to see this? Hello? You are able to see this?
Yes, sir.
Ah, so just I'm coming to that. So here is something interesting in the sense that we talked about technology, process. We will now see the materials, what material you can print. Methods we have already and the application. So that is why. Now you look at this one. What is this? What is this? Anybody? Hello? हाँ आकाश। हाँ हाँ, अरे यार मैं उसमें एक लेक्चर में हूँ, भेज दो किसी को ऊपर। हाँ मैं चैम्बर में हूँ, एक क्लास चल रहा है, भेज दो जरा से। हेलो मनीष जी, मनीष जी।
सर।
हेलो। तो
जी सर,
आर यू,
बोलिए।
ये स्क्रीन दिख रहा है ना?
दिख रहा है सर, दिख रहा है।
ये क्या है?
मैं पार्टिसिपेंट से रिक्वेस्ट रिक्वेस्ट करूंगा कि वो भी पार्टिसिपेट किया करें। सर ये कुछ आप नेचर से इंस्पायर्ड कर रहे हैं और अंदर की तरफ इसमें कोई जानवर है जिसको जैसे जाली में पैक किया है।
नहीं, ये रेशम का कीड़ा है।
हाँ वही मैं कह रहा हूँ कि छोटा सा कोई कीड़ा टाइप का है।
और
अगर
रेशम
ऐसे
का जो
मोबाइल
कीड़ा
में
है
आम
वो
आदमी
रेशम अपने
देखता है तो जैसे
अपने
सांप जैसा लग रहा है। बाकी पार्टिसिपेंट्स भी रिस्पॉन्ड करें सर को।
हाँ, तो रेशम का कीड़ा क्या करता है कि अपने लार से वो रेशम बनाता है और अपने शरीर के चारों तरफ वो उसको लपेट लेता है, क्योंकि उसको रहने के लिए जगह बनाता है, वो अपना घर बनाता है लार से, और उसी में रहता है। तो कैसे बनाता है? इट इज ए मटेरियल को डिपॉजिट करके बनाता है। सोचिए कितना फाइन रेशम का धागा होता है। ये कैसे, कितना इंटेलिजेंट है। यू नाउ यू सी द क्रिएटर, है ना? दैट इज द व्हाट ही, उसने, इस क्रिएटर ने, जिसको कॉकून कहते हैं, वो खुद से ही 3D प्रिंटिंग कर दिया। दैट इज व्हाट द 3D प्रिंटिंग प्रोसेस जो ह्यूमन ने अभी डेवलप किया है, ये इट इज इंस्पायर्ड फ्रॉम नेचर। यही नहीं है केवल, ये देखिए, लुक एट दिस। ये कुछ इंसेक्ट्स हैं, कुछ एंड्स हैं, जो कि रेनी सीजन में आप अक्सर देखे होंगे घरों में। ये कुछ मिट्टी के बनाते हैं अपने रहने के लिए, है ना? या अपने बच्चों का अंडा देने के लिए बनाते हैं ये आप सभी ने देखा होगा। या जैसे हनी भी बनाती है, अपना छत्ता बनाती है, खुद से बनाती है ना? कैसे बनाती है, कितना हेक्सागोनल रहता है। तो दैट इज द, किस, कहाँ से हुआ है वो डिजाइन, उसके पास कहाँ से आया? क्योंकि उसके दिमाग में है डिजाइन, उसके प्रैक्टिस में है। वो अपने मदर से अपने ग्रुप से सीखी है, एंड इट इज ट्रांसलेटेड हियर, है ना? ठीक है ना? ठीक है। नाउ लुक एट दिस वन, ये भी आपने देखा होगा। ये पेपर जो कागज होते हैं उसको भी पानी में घोल करके कुछ अलग तरह के जो इंसेक्ट्स हैं वो भी इस तरह के बनाते हैं स्ट्रक्चर। ये आप सभी ने देखा होगा, मोस्ट ऑफ यू। देखिए कैसे पत्तियों को काट करके अपने लार्वा लावा में मिला करके भी बनाया जाता है। तो ये कला नेचर से ह्यूमन ने सीखी, और फिर वो मशीन से जैसे जैसे 20th सेंचुरी और ये हुआ है तो उससे उन्होंने डेवलप किया इसको। और वही आज प्रोसेस शुरू में वो कहलाया प्रोटोटाइपिंग, और आज के समय में कमर्शियल नेम है उसका 3D प्रिंटिंग, और टेक्निकल नेम है जो एकेडमिक्स लोग यूज करते हैं उसको कहते हैं हम एडिटिव मैन्युफैक्चरिंग। अब देखिए मशीनिंग में हम कट करके नहीं बनाते हैं। मशीनिंग में जब ये कट करते हैं तो कितना हमारा मटेरियल वेस्ट होता है, लेकिन 3D प्रिंटिंग में केवल हम डिपॉजिट करके बनाते हैं। और यही प्रोसेस मैंने बताया आपको कैसे 4 स्टेप प्रोसेस है, दैट आई हैव ऑलरेडी एक्सप्लेन टू। और कैसे लेयर दिखा, देखिए लेयर कैसे बनाते हैं। जैसे ये मॉडल आपको प्रिंट करता है तो हर एक लेयर ऐसे ऐसे डिपॉजिट करते हैं एक एक के ऊपर। जैसे यहाँ पे मटेरियल नहीं है तो हमको यहाँ रखना पड़ेगा, तो वो उसको हम कहते हैं कि सपोर्ट जनरेट करते हैं। तो ग्रीन वाला हम सपोर्ट जनरेट करेंगे और जब प्रिंट करेंगे तो सपोर्ट मटेरियल अलग होगा जो कि बाद में हट जाएगा। डिफरेंट तरीके होते हैं लेयर को बनाने के लिए। सो 3D प्रिंटिंग जो है ये इस सेंचुरी का एक नया टेक्नोलॉजी है जो कि इट इज कमिंग। सो ये देखिए एक प्रोडक्ट का जो कि नंबर ऑफ लेयर्स कैसे दिखता है। ये देखिए देयर आर इन दिस पर्टिकुलर मॉडल देयर आर मोर देन 100 लेयर्स, और वो फिर जब एक के ऊपर डिपॉजिट होगा तो कैसे दिखेगा। ये टेक्नोलॉजी मैंने दिखाई दिया है। जनरली जो डेटा होता है लेयर का इस फॉर्मेट में होता है, कंप्यूटर डेटा, .stl फॉर्मेट कहते हैं। जैसे ये एक कोई मॉडल है तो उसको stl फॉर्मेट में किया तो इस तरह से ट्रेंगुलर डेटा होता है सारा, ढेर सारे। और उसका डेटा ऐसा, इसी को प्रोसेस करके वो फिर कैसे मशीन को गाइड करना है वो काम करता है। बहुत से कंप्यूटर हैं, यू कैन स्टार्ट वर्किंग ऑन दीज कंप्यूटर्स। और इकोनॉमिक्स तो बहुत है आज के समय में, वर्ल्ड में लाखों 3D प्रिंटर्स हो गए हैं। हाँ हेलो, हाँ बोलिए। भिजवा दीजिए, मैं एक लेक्चर में हूँ, बस आ रहा हूँ थोड़ा देर में। हाँ आएंगे। So the different materials that can be used is your plastics, polymer, ceramic, metals, clay, biomaterials, eatables. Eatables means जैसे खाने की चीजें हैं, और ये किसी भी फॉर्म में हो, चाहे लिक्विड की फॉर्म में हो, सॉलिड के फॉर्म में, पाउडर के फॉर्म में हो, दैट कैन बी प्रिंटेड है। ये SLA इज वन टेक्नोलॉजी, LOM ये हमने ऑलरेडी डिस्कस किया है, फ्यूज डिपोजिशन। देयर आर नंबर, आज के समय में करीब 30 to 35 डिफरेंट टेक्नोलॉजीज आ गई हैं। ये शुरू के प्रोसेसेस हैं जो मैं आपको दिखा रहा हूँ। Now application wise, let us come to the application. प्रोटोटाइपिंग का एप्लीकेशन मेडिकल सर्जरी में है, हेल्थ केयर में है, एडवांस रिसर्च में है, प्रोडक्ट प्रोटोटाइपिंग में, हिस्टोरिक प्रिजर्वेशन, आर्किटेक्चरल इंजीनियरिंग, कंस्ट्रक्शन, एडवांस मैन्युफैक्चरिंग, फूड इंडस्ट्रीज, ऑटोमेटिव, एसेसरीज, रैपिड टूलिंग एंड कास्टिंग, machine tool design, sculpturing, space exploration, automobile, police reconstruction, defense, military, like that. So these are the some of the applications. There are more applications. अब देखिए इसमें इफ डिफेंस भी आ गया, फिल्म इंडस्ट्री भी आ गई, स्कल्पचर भी आ गया, आर्ट एंड कल्चर भी आ गया, defense and military. Now let us see some of the items that has been printed. Now you look at, these are printed one. This is the fashion technology. अब आज के समय में फैशन इंडस्ट्री भी इसको यूज करने लगा है. लाइक दिस वन, दिस लेडी इज वियरिंग 3D प्रिंटेड क्लॉथ. यहाँ पे आप देखेंगे तो दिस इज द आर्किटेक्चरल डिजाइन, होल बिल्डिंग्स इन द एरिया कैन बी नाउ प्रिंटेड. ये यहाँ पे कुछ प्रोस्थेटिक्स है. Here it is another example of prosthetics to help the bicycle. These are another that can be 3D printed. ये 3D printed cloth है, cloth. ये bio bones can be printed. Prototyping, so that is all application of prototype. किसी का अगर खोपड़ी का स्कल फूट गया तो उस स्कल का भी प्रिंटिंग हो जा रहा है और फिर टाइटेनियम के उनको लगा भी दिया जा रहा है. दांत तो बनने ही लगे हैं, टीथ, और भी बॉडी ऑर्गन्स भी बनने लगे हैं. आप दो ही 4 साल में इंडिया में भी बॉडी ऑर्गन मिल जाएगा प्रिंटेड, जहाँ पे आपको किडनी और हार्ट ये सब प्रिंटेड मिल जाएगा. बहुत ही जल्दी आने वाला है. देखिए ये फैशन, ये जो क्लॉथ है, इट इज ए 3D प्रिंटेड क्लॉथ. These are another sculpture and other thing, modeling. This lady is also wearing a, हाँ आ जाओ. एक मिनट. So that's the beauty of, see this cloth. It is a transparent 3D printed cloth. Now these are the other designs. एयरपोर्ट पे जो आजकल आप डिजाइन देखते हैं वो भी कुछ ज्यादातर 3D प्रिंटेड करके फिर उसको बनाया गया है अलग तरीके से. Now see, this is the totally fashion technology case. How the clothes are designed, 3D printed cloths are designed. You can see this is a kind of hat, 3D printed hat. All these things are now possible, and it is big way it has appeared. ये आपका सिटी प्लानिंग और उससे है रिलेटेड. तो स्केलिंग, सी दिस द एयरपोर्ट के कुछ है जो बाहर आप देखते होंगे, इसमें लाइटिंग भी रखते हैं। तो इस जो 3D प्रिंटिंग है, इट इज ए स्केलेबल। स्केलेबल मीन्स जैसे आप प्रिंटर पे जब आप प्रिंट करेंगे तो छोटा है, लेकिन उसका तरीका है कैसे आप बड़े बना करके कर सकते हैं। ये देखिए, दिस इज वन एग्जांपल वेयर पूरी सिटी का एक आर्किटेक्चर को जरूरत था कि कैसा उनका प्लान लुक लाइक होगा, तो ये 3D प्रिंटेड है पूरी सिटी की प्लानिंग। ये बहुत इंटरेस्टिंग है। डिफरेंट तरह के फूड्स, डिफरेंट तरह के स्वीट्स यू कैन प्रिंट। So this is a printer which is this especially for designed a printer, especially for food printing. You can see, you can print and eat. ये chocolate printing machine है. You can have these all. This is another one where space exploration. अब जैसे already NASA ने और other people have made it. अब क्या है कि वहीं की मिट्टी से वहीं पे घर बनाना है, यहाँ से तो ले नहीं जाए, तो उन्होंने नासा ने कुछ प्रिंटर्स भेजे हैं उस ग्रहों पर, जैसे खास करके मंगल ग्रह पे, क्योंकि वहां से मिट्टी, वो प्रिंटर वहीं से मिट्टी लेकर के वहीं से वो प्रिंट कर देगा। तो इस तरह के भी बहुत से वर्क रिसर्च प्लान चल रहे हैं वर्ल्ड लेवल पे, क्योंकि हम यहाँ से बना के तो ले नहीं जाएंगे, तो हमको वहीं की मिट्टी से कैसे करना है, एक स्पेशल प्रिंटर बनाना होगा। तो पीपुल आर, लॉट ऑफ प्रोजेक्ट्स आर देयर। वही नहीं, बहुत से वर्क हैं जो कि वहाँ पे प्रिंटर भेज करके वहाँ पे प्रिंट करेंगे रिपेयर के लिए, स्पेस क्राफ्ट एक्सेट्रा। ये कुछ स्कल्पचर है जो कि जैसे बहुत सी हैं, हमारी मूर्तियां चोरी हो जाती है ना, स्मगलर्स, तो अब वो समय गया। अब जो भी मूर्तियां इस तरह इस कैटेगरी में है, उसको हम स्कैन करके कैड मॉडल बना के रख देते हैं, और जब भी प्रिंट करना चाहेंगे प्रिंट कर सकते हैं। तो अब उसकी वैल्यू ऑलमोस्ट नहीं है। जैसे एक ये नंदी महाराज है, तो इनको इस प्रिंट करके रखा गया है, और कभी भी प्रिंट करना है तो कर सकते हैं। तो कोई चोरी भी ले गया तो अब उसकी वैल्यू नहीं रहेगी। ये स्पेस एक्सप्लोरेशन का एप्लीकेशन है 3D प्रिंटिंग की वजह की तरफ से। These are another some of the things. बहुत पॉपुलर टेक्नोलॉजी है। सोलर प्रिंटिंग एक एरिया है जहाँ पे कि सोलर एनर्जी को यूटिलाइज करके, जैसे जहाँ पे नदियों के किनारे या समुद्र के किनारे जहाँ पे सैंड है, तो सोलर प्रिंटर ये एक कहलाता है, जहाँ पे कि सोलर सन की रेस से ही इसको मेल्ट करते हैं एक पर्टिकुलर फैशन में, कैड मॉडल के अनुसार, और वो फिर ये ग्लास में कन्वर्ट हो जाता है। तो ये सब जो प्रोडक्ट है, ये बड़ा ही होटल्स एक्सेट्रा में डेकोरेटिव की तरह से यूज हो रहा है। इसको कहते हैं सोलर 3D प्रिंटिंग। यहाँ पे हाउस प्रिंटिंग का है। अब आज के समय में मिट्टी के घर बनाना या कंक्रीट के घर बनाना 3D प्रिंटिंग के से बहुत इजी हो गया है। आपने अक्सर न्यूज़ सुना होगा कि चाइना ने या जापान ने 3 स्टोरी 4 स्टोरी बिल्डिंग, बड़ी बिल्डिंग, फ्लैट्स 24 घंटे में बना ले रहे हैं। तो यस, वो उस तरह के प्रिंटर अवेलेबल हैं। हमारे भी लैब में एक क्ले प्रिंटर है, जैसे हम लोगों ने उसमें क्ले के मॉडल्स प्रिंट किए हैं। आप, इफ यू वांट टू वर्क इन that direction, you can visit our lab. This is the same thing, solar printing। और बहुत स्टूडेंट्स में बहुत हॉबी की तरह से भी ये 3D प्रिंटिंग आ गया है। बहुत से कंपटीशंस होने लगे हैं 3D प्रिंटिंग से डेवलप करने के लिए प्रोडक्ट। बहुत सी बड़ी बड़ी कंपनियां प्रॉब्लम दे करके स्टूडेंट को लेते हैं, उनको एक समय सीमा में प्रोडक्ट डेवलपमेंट करके प्रोटोटाइप डेवलपमेंट करने की, इस तरह का ये एक कल्चर आ गया है. एंड दिस इज व्हाट आई विल close it here. If any question you may ask, please. Yes. If there is any question, you are most welcome. Manish ji, Deepshika,
Yes, sir.
is there any question?
No, sir.
So
Thank
I
you so
hope.
much, sir.
Thank you, sir. So I think I was able to deliver the relevant portion. Manish ji, thank you. Thank you all. If there is no question, then I can close. Okay, sir. Manish ji, Manish ji, hello.